Sometimes the defect that we want to inspect is not visible to us. It does not mean that the defect is not there, it just means that the human eye is not able to detect the defect that emits a special wavelength. This is where multi- and hyperspectral imaging comes in handy. To understand what multi- and hyperspectral imaging is, it's good to start with the understanding of light. What is light? Light is electromagnetic waves created by vibrating electronic charges. It's a little bit like sound. Sound is air pressure waves created by a vibrating loudspeaker. Light waves can have different wavelengths. Here you see the electromagnetic spectrum. Light can have many different wavelengths. Light waves with wavelengths in this area is called the visual spectrum. You have light at around, with this wavelength of 450. The human eye perceives this as blue. This wavelength is perceived as green, and this wavelength is perceived as red. But the human eye can only see this spectrum. But there are other interesting spectrums. Above the red light, we have the infrared light, and below the blue, we have the ultraviolet. Luckily, electronic sensors can detect these light ranges. So, electronic devices can see outside the visual spectrum. Take a euro banknote, for example. When we look at it, it looks perfectly normal. However, what happens if we put this in the infrared light spectrum underneath an electronic sensor? So what is interesting here? In this setup, we have an electronic sensor that sees in the infrared light spectrum. We also have infrared light coming to the banknote. To us, the banknote looks perfectly normal. However, for the camera that looks in the infrared light, over you see here, half of the banknote is actually invisible. What is interesting here is that outside the visual spectrum, there are more information than what we know. Another example is fruit. You know, when you take an apple home from the store, and after a few days you find out it becomes rotten because it has a bruise. The problem is our eyes cannot easily detect that it has a bruise. However, in the shortwave infrared light, we can actually magically see the bruise. Here, in this picture, we see the apple in the visual spectrum. We cannot see the bruise. In this case, we've taken an image of the same apple, but in shortwave infrared light. And it suddenly appears you can see the bruise. Nuts in wood is another example where multispectral and hyperspectral imaging can help us. Some wood nuts have the same color as the wood. So in the visual spectrum, we cannot see the difference. But if we look closer at the wavelengths, we can utilize that the nut resin reacts to special wavelengths. So if we find these wavelengths and only look at those, the resin in the nuts will make all the nuts detectable, even though it is not detectable in the visual spectrum. So working with multi- and hyperspectral imaging can be challenging, but it provides a unique opportunity to see the invisible. If you are interested, please contact us. We will be able to help you and analyze your problem and see if multi- or hyperspectral imaging can help.